Hi, and welcome back. In this lecture, we're going to talk about Key Insight 3, Digital Transformation and Technological Breakthroughs. Well, there are quite a number of innovative digital tools and technologies that we can use to address the challenges of the environmental management industry. So first, if you look at things like air pollution, digital technologies like the Internet of Things, which is basically smart systems and sensors which are able to provide real-time telemetric data. So things like the temperature levels, particle levels, oxygen levels, nitrogen levels, and things like nitrogen oxide levels, carbon monoxide levels, and all these toxic gases and fumes in real time to a centralized storage location. There's also things like cyber-physical systems. So these are systems which are smart, which means it can self-organize, self-optimize, and self-learn with minimum human intervention. So it can basically understand the environment and adapt itself. Then there are things like big data analytics. So these are powerful analytical tools which can take data from multiple sources and understand hidden patterns and trends. So all these systems are able to provide significant value to study, to control and manage, and also predict air pollution in cities all around the world. And also we can aggregate the data to see how the country is doing, how different regions are doing, and also globally how we are doing as well. Then we have things like transforming the relevant processes. So we can use these technologies to understand what's working and what's not, and also to accurately determine whether our solutions to address those challenges and problems are actually impactful and working. Then we can use these technologies to do continuous optimization, meaning it can understand and further reduce the emission levels by optimizing the processes, maybe continuously checking the temperature and running the cooling systems periodically when the temperature is above a certain parameter or threshold, rather than running the cooling systems continuously. So dynamic operations like that can be done using these advanced technologies. Then let's look at carbon dioxide emissions. So digitization of the business operations for better monitoring of emissions. So then we have things like carbon capturing technologies which are able to capture carbon from industrialized processes and store them underground and also monitor them continuously. Then there are things like accelerating the research and development. So R&D acceleration can also be done because using things like artificial intelligence helps us to understand and analyze thousands of possible processes and products and services which can work under our constraints and resources and scenarios. So we can also accelerate the number of products and services which are commercially viable. So products and services which actually come out of the R&D activities, because only about 5% or even less are commercially viable. Then we have water treatment, so efficient energy usage, so continuously monitoring the energy levels. Then we have things like demand forecasting, so accurately forecasting the demand. So this is very useful for us to ensure the supply and demand are met, but also for our future capacity planning activities. Then we have things like proactive maintenance, which is basically understanding what component will fail before it breaks. So using digital tools and technologies, we can do that as well. So this will ensure continuous availability of water resources and water treatment facilities. Then there are things like reducing wastage, so accurately determining the amount of chemicals required to purify the water and things like that. Then the systems are also intelligent, meaning it will continuously improve and evolve to increase the efficiency and productivity of business operations and processes. Then there's also analytics which we can derive, so we can understand the hidden trends and patterns and insights about the customer trends, behavior patterns, and also so many other things. Then we have things like climate change and disaster management. So measuring emissions, understanding seawater levels, real-time capturing of telemetric data like temperature, humidity, salinity, and things like that. And also using analytics to identify trends and patterns. So we can see how certain telemetric data like humidity, temperature, salinity have evolved. Then moving on to solid waste management. So we can also improve the energy efficiency used for processing waste. Now there's also things like waste energy generation, so we can generate electricity from waste as well. So using technology, we can now easily do waste categorization and sorting as well. Then there are things like real-time telemetric data of the waste levels in the bins. So sharing that data with the municipal council and the city councils, and sharing that data with the garbage trucks as well, so they know what to collect and where to collect from. Then there's things like sharing the arrival of garbage trucks with the public, so they can know at what time the garbage truck is coming. So some sort of app like Uber where we can see in real time at what time the garbage truck is coming and where it is right now. So then there's greater collaboration which can be facilitated using these digital technologies. So better coordination and communication between city councils, waste disposal companies, factories, and the general public. Then we have another major challenge, which is e-waste. So due to the massive popularity of electronics, now we have an electronic waste or e-waste problem. So we can use a lot of digital tools to increase the energy efficiency for processing waste, extracting precious metals like copper and gold, and also deriving analytics from it. Moving on, talking about food waste, we can measure the wastage, productivity and efficiency of processes in real time, and also we can do research and development using these advanced technologies like artificial intelligence and machine learning to come up with alternatives for things like meat and also crops which are more climate resistant and disaster resilient. And also the supply chains will be continuously optimized, meaning things like routing, coming up with much more efficient routes, delivery plans, scheduling, demand forecasting, and also ensuring that the supply and the demand are matched very well. Then we have agri-waste, so measuring wastage, productivity and efficiency in the processes in real time. So upcycling is also there, meaning repurposing the wastage for something like livestock feed. Then there's continuous optimization as well. So things like storage and inventory can be continuously optimized using things like IoT or Internet of Things. And there's also analytics which we can derive from to understand the patterns and insights. Then there's sustainable supply chain. So we can use these digital tools to measure and continuously optimize the operations, real-time asset utilization and optimization, reducing wastage, improving the productivity and efficiency, and also to derive very good analytics to understand what's working and what's not, and also to formulate strategies and national importation exportation plans, and to basically make things better for everyone. Well, that's about it for Key Insight 3, digital transformation and technological breakthroughs in a very summarized manner. So we're going to talk about much more of these under Industry 4.0 applications and impact. So I'll see you on another lecture.